Hello dear students. So welcome back to my video lecture 9 on S block elements. Hope you have watched my previous videos. So what was that we were discussing in the previous video? Yes, we were talking about the different compounds of alkali metals and alkaline earth metals, isn't it? We started with the discussions of the compounds of sodium. I have told you we have got to discuss the compounds like sodium hydroxide, sodium carbonate, sodium thiosulfate, oxides of potassium, potassium iodide, isn't it? And the different compounds of alkaline earth metals like compounds of calcium like calcium hydroxide, calcium carbonate, calcium oxide, calcium sulfate, etc, etc. So now we shall continue with our lecture series. So hope you remember where we have stopped in the last video. Where did we stop in the last video? Yes, we just started with the preparation of what? Sodium hydroxide. What is the method of preparation of sodium hydroxide? Yes, we prepared sodium hydroxide by using a mixture of sodium carbonate and calcium hydroxide. When sodium carbonate reacts with calcium hydroxide, it gives what? Sodium hydroxide, and what else? Calcium carbonate, isn't it? Calcium carbonate. So this is how we prepare sodium hydroxide. By the way, what is the common name of sodium hydroxide? The common name of sodium hydroxide is called as caustic soda. Why is it called as caustic soda? I have told you. Why is it called as caustic soda? Because it is corrosive in nature. That is why it is called as caustic soda. It's a strong base. It exists in the form of pellets. It's a white crystalline solid, isn't it? It's a white crystalline solid. It has deliquescent property. That means it has water absorption capacity. It has a soapy touch. So we discussed the various the physical properties of sodium hydroxide also. Now we have got to discuss the chemical properties of sodium hydroxide. Yes, the chemical properties of sodium hydroxide. What are the chemical properties that we have got to discuss here? Yes, I have listed out also in the last video, isn't it? Yes, we have listed out also. What are the different chemical properties of sodium hydroxide that we have got to discuss? Yeah, we have to discuss the reactions of sodium hydroxide with yes, first one, what is that? Amphoteric metals. Which are the amphoteric metals? Yeah, it is, come on, yes, tin, lead, aluminium, zinc, copper, and these are called as what? Yes, amphoteric metals, isn't it? We have to learn the reaction of sodium hydroxide with these amphoteric metals. What else? Yes, come on, we are supposed to learn the reaction of sodium hydroxide with carbon dioxide, then with sulfur, then with halogens. Is it correct? Yes, then with what? Halogens, and then with what? Metal ions, correct? And lastly, with a very important reaction, very important reaction with, yes, mercuric ion and ammonium ion. With mercuric ion and ammonium ion. Well, we have got to discuss all these chemical properties of sodium hydroxide, having finished all the physical properties and the preparation of sodium hydroxide. So shall we start one by one now? Yes, now we will discuss the reaction of sodium hydroxide with amphoteric metals. By the way, we have finished all these reactions in our previous videos also. We have written the same reaction in the previous chapter, that is hydrogen also. But still, let us memorize all the reactions and let us see how sodium hydroxide reacts with these amphoteric metals. Yes, so amphoteric metals like yes, which are those? Zinc, copper, aluminium, tin and lead. They react with sodium hydroxide. They react with sodium hydroxide. Okay, yes, all these what do you mean by amphoteric metals? What are amphoteric metals? The metals which react with both acid as well as base. Okay, when these metals can react with acids, okay, and they liberate hydrogen gas. Okay, the same metals will also react with base such as sodium hydroxide. Here also they liberate hydrogen gas. They liberate which gas? Hydrogen gas. Such metals are called as amphoteric metals. Hope you can remember this. Okay, yes, yeah. Okay, can you remember all this? Yeah, these metals are called as what? Amphoteric metals. Amphoteric metals. So what happens when these amphoteric metals react with sodium hydroxide? They form peculiar compounds. They form peculiar compounds with the liberation of hydrogen gas. They liberate which gas? Hydrogen gas. Okay, yes, in all the cases they liberate hydrogen gas and they form peculiar compounds. Look here, zinc reacts with sodium hydroxide to form what? Na2, okay, ZnO2. What is this called as? This is called as sodium zincate. Sodium zincate, and hydrogen gas will be liberated. Copper reacts with, okay, sodium hydroxide to form what? Yes, Cu2 ZnO2. This is called as copper, okay, Na2, okay, CuO2, Na2CuO2. This is called as sodium cuprate. Okay, next aluminium reacts with sodium hydroxide to form what? Okay, NaAlO2. Okay, what is it? Sodium aluminate. Okay, now yes, tin reacts with sodium hydroxide to form what? Na2SnO2. Sodium, okay, sodium, yes. Now what is this? Sodium stannous. Okay, then okay, sodium hydroxide reacts with lead to form what? Na2PbO2. What is this? Okay, sodium plumbate. Okay, sodium plumbate, sodium stannate, okay, sodium aluminate, sodium cuprate, and sodium zincate. Yes, so like these, when these okay, amphoteric metals reacts with this strong base like sodium hydroxide, no doubt they liberate hydrogen gas. Along with the liberation of hydrogen gas, they form peculiar compounds like sodium zincate, sodium cuprate, okay, sodium aluminate, sodium stannate, and sodium plumbate. Sodium plumbate. Okay, yes, any doubts? Yeah, that is about the first reaction of sodium hydroxide with amphoteric metals. Okay, clear? Yes, so please pause the video and note down this, okay, reactions. You don't have to worry about balancing the redox reaction, which I have kept telling you in each and every video. Don't worry about balancing the redox reaction, balancing the reactions, because we have learned balancing the redox reaction in balancing the reaction in redox reactions. So no need to balance. You know, if at all, if you want to balance these reaction, apply the rules that we have studied under redox reactions. Okay, apply the rules that we have studied under redox reaction and balance these reaction. But there is no necessary that you have to balance these reaction. Just remember what happens when these, okay, amphoteric metals reacts with a strong base like sodium hydroxide. There will be evolution of hydrogen gas and some peculiar compounds are formed. Okay, remember the formula of these compounds. That's it. That is more than enough. Okay, clear? Yes. Okay, now what happens when, okay, sodium hydroxide, next is a simple reaction. Simple reaction. What happens when, okay, sodium hydroxide reacts with carbon dioxide? Okay, what happens when sodium hydroxide reacts with carbon dioxide? Okay, yes, I have discussed this. Okay, yes, under the formation of carbonates of alkali metals and alkaline earth metals. What I have told you there, okay, when the oxides and hydroxides, when oxides and hydroxides of alkali metals and alkaline earth metals react with carbon dioxide. Okay, have I not told you this? When oxides and hydroxides of alkali metals as well as alkaline earth metals, okay, when they react with carbon dioxide, they form carbonates, isn't it? They form what? Carbonates. Now the same thing, okay, sodium hydroxide, when it reacts with carbon dioxide, okay, yeah, again I'm repeatedly telling you, never worry about balancing the reaction, okay. When sodium hydroxide reacts with carbon dioxide, okay, it's going to form what? Sodium carbonate, okay. How do I write the reaction? How to write the formula of sodium carbonate? See, I told you, please remember the previous video, okay. So whenever you are writing the product, you have to interchange the ions, isn't it? You just have to interchange the ions, okay. Which are the ions here? Yeah, the ions in sodium hydroxide is Na plus and OH minus, isn't it? Na plus and OH minus. Now, what about carbon dioxide? Carbon dioxide is a covalent compound. It will not ionize. That means it doesn't have any ions. Okay, in such case, what have I told you? Okay, in such case, whenever you find a covalent compound, you try to dissolve it in water. Okay, when carbon dioxide dissolves in water, what is it going to form? It will form, okay, carbonic acid, H2CO3. Now, which are the ions present in carbonic acid? Which are the ions present in carbonic acid? The ions present in carbonic acid is 2H plus ions and CO3 2 minus ion. Am I correct? So now interchange the ions, Na plus ions with CO3 2 minus. Okay, yeah, okay. So you'll be interchanging Na plus ions with what? CO3 2 minus. Again, crisscross method. Okay, now interchange the charges. Okay, plus minus 2 charge here and plus 1 charge here. What is the formula of sodium carbonate? It is Na2CO3. Is that correct? Now H plus ion will combine with OH minus ion to form what? Water. Am I correct? Okay. So like this, when any oxides and hydroxides of alkali metals and alkaline earth metals react with carbon dioxide, they will always form what? Sodium carbonate. Sodium carbonate. Okay, simple, such a simple reaction. Now very important, okay, reaction of sodium hydroxide with sulfur. Okay, reaction of sodium hydroxide with sulfur. Yes, okay, very important reaction, which has been asked many times in NEET. Okay, yes, what happens when sodium hydroxide, okay, reacts with sulfur? Okay, by the way, what is the oxidation state of sulfur here? Okay, in redox reactions, I have told you, if there is any element in uncombined state, then the oxidation state of that element is going to be what? 0. Okay, isn't it? That means in this reaction, okay, sulfur is in 0 oxidation state. So guys, please note this point. Okay, if you find any reactant in 0 oxidation state, then that reaction, okay, is going to be a disproportionation reaction. What is that reaction going to be? It is going to be disproportionation reaction. What do you mean by disproportionation reaction? Okay, yes, did we learn this in redox reaction? Yes, we have learned about disproportionation reaction in redox reactions, isn't it? Okay, so whenever you find, okay, any element, okay, or if you find a reactant in 0 oxidation state, okay, then definitely the reaction is going to be a disproportionation reaction. What do you mean by a disproportionation reaction? Try to recall that we have studied in redox reaction. So in a reaction, particularly in a redox reaction, if same element undergoes oxidation as well as reduction, okay, in a redox reaction, if a same element undergoes oxidation as well as reduction, then that reaction is called as what? Disproportionation reaction. Am I correct? Okay, so like that, see, whenever sodium reacts with when sodium hydroxide reacts with sulfur, so in this reaction, sulfur is both oxidized as well as reduced. Okay, in the same reaction, the same element is both oxidized as well as reduced. Such a reaction is called as disproportionation reaction. Hope you noted this point. Okay, what is that point? Very important point. What is it? In a reaction, if you find any reactant, okay, we will see so many examples now of such kind. Okay, yes, if you find any reactant in zero oxidation state, then that reaction can definitely be what type of reaction? It will be a disproportionation reaction. That means in this reaction, so sulfur will be both oxidized as well as reduced. Okay, see, look here, sulfur will be oxidized, okay, to as well as reduced. Now, what are the products? That means you are supposed to write the oxidized form as well as the reduced form of sulfur. Okay, see, whenever sodium hydroxide reacts with sulfur, it will form sodium sulfide. What is this? Sodium sulfide plus Na2S2O3. This is called as sodium, okay, thiosulfate. Okay, what is this called as? Sodium thiosulfate. Sodium thiosulfate. Okay, what is the oxidation state of sulfur here? Okay, the oxidation state of sulfur in sodium sulfide is -2. Okay, and what is the oxidation state of sulfur in sodium sulfide? Just check. Yes, this is +1. This is -2. You'll be getting 2 into +1 plus 2x plus 3 into -2 is equal to 0, isn't it? Okay, yes, 2 plus 2x minus 6 is equal to 0, 2x minus 4 is equal to 0, x is equal to +2. You will get the oxidation state of sulfur to be what? +2. Now compare here. Sulfur is going from 0 to -2. Okay, sulfur is going from 0 to -2. That means there is decrease in oxidation number. If there is decrease in oxidation number, what do you call that? As reduction reaction, isn't it? Okay, and compare from here to here. Okay, from here to here. Okay, it is going from 0 to +2 state. It is going from 0 to +2 state. There is increase in oxidation number. If there is increase in oxidation number, what do you call that reaction as? Oxidation reaction. Oxidation reaction. Look here, the same element is undergoing both oxidation as well as reduction reaction. What do you call such reactions as? Okay, disproportionation reaction. Simple. So, okay, so when sodium hydroxide reacts with sulfur, it will undergo disproportionation reaction to give sodium sulfide, sodium thiosulfate as well as water. Okay, sodium thiosulfate as well as what? Water. Okay, simple. Yes, that is how, okay, sodium hydroxide reacts with, that is how sodium hydroxide reacts with what? Sulfur. Okay, next, how does, again, very important, these reactions are now important. Okay, yes, how does sodium hydroxide reacts with halogens? Okay, how does sodium hydroxide reacts with halogens? Okay, see, these questions have been asked so many times in NEET examination, so I want you to concentrate here. What happens when sodium hydroxide reacts with halogens? So here we will be learning two cases. Okay, two different reactions. We will be talking about two different reactions. Okay, yes, look at here. Reaction of sodium hydroxide. First case, reaction of sodium hydroxide with, okay, cold and dilute halogens. Okay, cold and dilute halogen. The next case is going to be, okay, the next case is going to be reaction of sodium hydroxide with hot and concentrated halogens. Okay, hot and concentrated halogens. Are you getting my point? Okay, so we are learning two different reactions of sodium hydroxide with halogens. One is reaction of sodium hydroxide. Okay, I will tell you, this is, okay, very important reaction. Okay, very important reaction. Reaction of sodium hydroxide with cold and dilute halogen. Reaction of sodium hydroxide with hot and concentrated halogen. What is going to happen? Look here. Okay, now what happens when sodium hydroxide reacts with cold and dilute NaOH, and what happens when sodium hydroxide reacts with hot and concentrated NaOH? Okay, see, in both the cases sodium halide is formed. Okay, in both the cases sodium halide and water is formed. Okay, no doubt in it. sodium halide and water is formed. But there is one different product in both the cases. There is one different product in both the cases. Okay, look here. When sodium hydroxide reacts with cold and dilute halogens, okay, it is going to form sodium halide, okay, sodium hypohalide or sodium oxyhalide, okay, plus water. Whereas when sodium hydroxide reacts with hot and concentrated halogens, okay, when it reacts with hot and concentrated halogens, it is going to form sodium halide, okay, sodium NaXO3. Look at here, we're going to form this compound, okay, we're going to get this compound NaXO3 plus water. Are you able to feel the difference here? Okay, with cold and dilute NaOH, sorry, with cold and dilute halogens, you should remember the formation of sodium oxyhalide, okay, whereas the other two products seems to be the same in both the cases. Whereas in hot and concentrated NaOH, or sorry, hot and concentrated, okay, halogen. Now look here, yes, okay, with hot and concentrated, okay, NaOH, sorry, this is cold and dilute NaOH, hot and concentrated NaOH, okay, yes, halogen is reacting with cold and dilute NaOH and halogen is reacting with hot and concentrated NaOH. So with hot and concentrated NaOH, what is the product form? The product is going to be NaXO3. Are you getting my point? Yes, please remember these, okay, difference. Whereas in both the cases, sodium halide, okay, and water, sodium halide and water, these two products are common, whereas these two are different. These two are different. So for example, what happens when chlorine reacts with cold and dilute NaOH? Okay, what happens when chlorine reacts with cold and dilute NaOH? Well, when chlorine reacts with cold and dilute NaOH, it is going to form what? Sodium chloride, okay, water and sodium, okay, oxychloride. Sodium oxychloride. Whereas, okay, sodium, what happens when chlorine reacts with hot and concentrated NaOH? Okay, when chlorine reacts with hot and concentrated NaOH, it's going to form sodium chloride, then NaClO3 plus what? Water. Did you observe the difference? Okay, but the reaction proceeds in a different way when, okay, sodium hydroxide reacts with fluorine. There is a difference again. Okay, again I'm telling you, there is a difference. I want you to, okay, stress more on this reaction, more and more, as many times as you can on these reactions, okay, because there is a lot of concepts here. Okay, so this is how when sodium hydroxide, this is how when, okay, halogens, which halogens? When chlorine, bromine and iodine, okay, when chlorine, bromine, iodine, okay, reacts with cold and dilute NaOH, hot and concentrated NaOH, this is how the reaction goes. But when fluorine reacts with sodium hydroxide, the reaction seems to be different. The reaction will go in a different way and different products are formed. Which are the different products here? Look here. When, okay, fluorine reacts with cold and dilute NaOH, okay, when fluorine reacts with cold and dilute NaOH, no doubt it will form sodium fluoride and water. Along with sodium fluoride and water, you will get oxygen difluoride. Okay, please note this point. What is that? You're going to get oxygen difluoride with cold and dilute NaOH. Whereas when fluorine reacts with hot and concentrated NaOH, when it reacts with hot and concentrated NaOH, here we're going to get sodium fluoride, water. This is common. Okay, whereas with hot and concentrated NaOH, it is going to form fluorine gas. Fluorine gas will be liberated. This is what the difference is. Okay, so shall we summarize this quick? Yeah. Okay, now what is that you're going to get? Okay, yes. Look at here. Okay, just a minute. Okay, so what is going to happen here? So we have a reaction of halogens. Okay, so halogens in particular what? Chlorine, bromine, okay, and iodine. Okay, yes, when they react with, okay, yes, cold and dilute, okay, NaOH, cold and dilute NaOH, what are the products? Sodium halide, sodium oxyhalide plus water. Okay, can you remember this? Correct. Okay, and when the same halogens reacts with, okay, hot and concentrated NaOH, hot and concentrated NaOH, okay, concentrated NaOH, what are the products formed? Yes, we'll be getting sodium halide plus NaXO3 plus H2O, NaXO3 plus what? H2O. Okay, simple. Yes. Now what about fluorine? Okay, I told you fluorine will, okay, react in a different way. Okay, fluorine will react in a different way. Okay, how does fluorine reacts with, okay, cold and dilute NaOH? Okay, when fluorine reacts with cold and dilute NaOH, the products are sodium fluoride, yes, and then what? Oxygen difluoride plus water. Okay, whereas with hot and concentrated NaOH, we will be getting sodium fluoride plus fluorine plus water. Fluorine plus water. Is that simple? Okay, very nice. Now, next, with metal ions, how does sodium hydroxide reacts with metal ions? Okay, now look here. Okay, yes, when sodium hydroxide, okay, when sodium hydroxide, yes, sodium hydroxide reacts with metal ions, okay, yes, such as, okay, ferric ions, yes, copper ions, okay, aluminium ions, okay, then, okay, manganese ion, and then nickel ion, chromium ion. Okay, look at here, when sodium hydroxide reacts with these metal ions, they form colored compounds. They form what? Colored compounds. Okay, let us understand the reactions and let us understand the various colors that are formed. So, as I was telling you, when sodium hydroxide reacts with these metal ions, okay, they form colored compounds. Let us understand the reaction and let us understand what are the different colored compounds that are formed when the sodium hydroxide, okay, reacts with these metal ions. Okay, so we have ferric ions, okay, reacting with sodium hydroxide, okay, copper ion reacting with sodium hydroxide, okay, then aluminium ion reacting with what? Sodium hydroxide, manganese ion, okay, reacting with sodium hydroxide, okay, then nickel ion, yes, nickel ion, okay, reacting with what? Sodium hydroxide, and lastly chromium ion reacting with sodium hydroxide. Chromium ion reacting with sodium hydroxide. Yeah, okay, Cr3 plus ion reacting with what? Sodium hydroxide. See, okay, hope you know the way with which you can write the reaction. Look at here, when chromium reacts with sodium hydroxide contains Na plus and OH minus ion. You have to interchange what ions? This cation will react with this anion, isn't it? Okay, that means chromium ion will react with hydroxyl ion. Just interchange the charge, okay? Yes, crisscross method. So 3, you're going to multiply here with 3 and you're going to multiply 1 here with chromium. So what is the product form? It is going to be what? CrOH thrice, okay? Do you remember this? Okay, yes, so that means when chromium reacts with sodium hydroxide, sodium hydroxide is going to form what? Chromium hydroxide. Okay, in all the cases sodium ions are formed. Okay, yes, when ferric ions reacts with sodium hydroxide, it's going to form ferric hydroxide plus Na plus ion. Okay, copper reacts with NaOH to form what? Copper hydroxide, cupric hydroxide plus Na plus. Okay, aluminium ion reacts with sodium hydroxide to form aluminium hydroxide, okay, plus sodium ion. Then okay, manganese ion reacts with sodium hydroxide to form manganese hydroxide, okay, plus Na plus ion. Okay, nickel ions react with sodium hydroxide to form nickel hydroxide plus Na plus ion. Okay, please remember, no, this is not important. What is important is the color. What is the color of chromium hydroxide? Okay, yes, it's a green colored compound. It's a green colored compound. Okay, ferric hydroxide, I hope you know the color of rust. What is the color of rust? It is brown colored compound. Okay, obviously you know the color of copper ion. What is the color? Blue colored. Okay, copper hydroxide, cupric hydroxide is a blue colored compound. Aluminium hydroxide is a white compound. Manganese hydroxide is pink compound. Okay, and nickel hydroxide is again a green colored compound. So you should remember the color of these compounds. Okay, that is what is important. Understood? Okay, chromium hydroxide is green colored compound. Okay, ferric hydroxide is a brown colored compound. Cupric hydroxide is a blue colored compound, and aluminium hydroxide is a white colored compound. Manganese hydroxide is pink colored, whereas nickel hydroxide is a green colored compound. Okay, okay students, I hope okay you have understood. Now I'm going to continue with the last chemical property of sodium hydroxide, okay, with mercuric ions and ammonium ions in the next video. Okay, thank you.